Promises give us a way to make sense out of asynchronous behavior. When making an asynchronous request, one of two things can happen: everything goes as we hope, or there's an error. There may be several different types of successful or unsuccessful requests. For example, we could try several ways to obtain the data to reach success. We could also receive multiple types of errors. Promises give us a way to simplify back to a simple pass or fail. Let's create an asynchronous promise for loading data from the randomuser.me API. This API has information like email address, name, phone number, location, and so on for fake members, and is great to use as dummy data. The getForKemembers function returns a new promise. The promise makes a request to the API. If the promise is successful, the data will load. If the promise is unsuccessful, an error will occur. Const getForKemembers equals count equals new promise array solves rejects equals const API equals https://api.randomuser.me/nat equals useResults equals count. Const request equals new smushed request. Request.openGet API. Request.onload equals request.status equals 200. Resolves JSON.parser request.response.results. Reject error request.status text. Request.oneError equals reject set. Request.send. With that, the promise has been created, but it hasn't been used yet. We can use the promise by calling the getForKemembers function and passing in the number of members that should be loaded. The then function can be chained on to do something once the promise has been fulfilled. This is called composition. We'll also use an additional callback that handles errors. getForKemembers 5.then members equals console.log members equals console.error. New error cannot load members from randomuser.me. Promises make dealing with asynchronous requests easier, which is good, because we have to deal with a lot of asynchronous data in JavaScript. You'll also see promises used heavily in Node.js, so a solid understanding of promises is essential for the modern JavaScript engineer. Classes. Previously in JavaScript, there were no official classes. Types were defined by functions. We had to create a function and then define methods on the function object using the prototype. Function vacation destination, length. This dot destination equals destination, this dot length equals length. Vacation.prototype.print equals function. Console.log this dot destination, this dot length days. Var Maui equals new vacation Maui, 7. Maui.print // Maui 7. If you were used to classical object orientation, this probably made you mad. S6 introduces class declaration, but JavaScript still works the same way. Functions are objects, and inheritance is handled through the prototype, but this syntax makes more sense if you come from classical object orientation. Class vacation. Constructor destination, length. This dot destination equals destination, this dot length equals length. Print. Console.log this dot destination will take this dot length days. Capitalization conventions. The rule of thumb with capitalization is that all types should be capitalized. Due to that, we will capitalize all class names. Once you've created the class, you can create a new instance of the class using the new keyword. Then you can call the custom method on the class. Const trip equals new vacation Santiago, Chile, 7. Console.logtrip.print // Chile will take 7 days. Now that a class object has been created, you can use it as many times as you'd like to create new vacation instances. Classes can also be extended. When a class is extended, the subclass inherits the properties and methods of the superclass. These properties and methods can be manipulated from here, but as a default, all will be inherited. You can use vacation as an abstract class to create different types of vacations. For instance, an expedition can extend the vacation class to include gear. Class expedition extends vacation. Construct a destination, length, gear. Superdestination, length. This.gear equals gear. Print. Super.print. Console.log bring your this.gear.join and your. That's simple inheritance. The subclass inherits the properties of the superclass. By calling the print details method of vacation, we can append some new content onto what is printed in the print details method of expedition. Creating a new instance works the exact same way. Create a variable and use the new keyword. Const trip equals new expedition Mount Whitney, 3. Sunglasses, prayer flags, camera. Trip.print. / Mount Whitney will take 3 days. / bring your sunglasses and your prayer flags and your camera. Classes and prototypal inheritance. Using a class still means that you are using JavaScript's prototypal inheritance. Log vacation.prototype, and you'll notice the con. Structure and print details methods on the prototype. We will use classes a bit in this book, but we're focusing on the functional paradigm. Classes have other features, like getters, setters, and static methods, but this book favors functional techniques over object-oriented techniques. The reason we're introducing these is because we'll use them later when creating React components. 3. Mozilla Developer Network, JavaScript code modules. 4. Mozilla Developer Network, using JavaScript code modules. S6 modules. A JavaScript module is a piece of reusable code that can easily be incorporated into other JavaScript files. Until recently, the only way to work with modular JavaScript was to incorporate a library that could handle importing and exporting modules. Now, with S6, JavaScript itself supports modules. 3. JavaScript modules are stored in separate files, one file per module. There are 2 options when creating and exporting a module. You can export multiple JavaScript objects from a single module, or one JavaScript object per module. In example 2-6, TextHelpers.js, the module and 2 functions are exported. Example 2-6. TextHelpers.js. Export const print message equals log message, new date. Export const log message, timestamp equals console.log timestamp.toString message. Export can be used to export any JavaScript type that will be consumed in another module. In this example, the print function and log function are being exported. Any other variables declared in TextHelpers.js will be local to that module. Sometimes you may want to export only one variable from a module. In these cases you can use export default example 2 to 7. Example 2 to 7. /m tfreal.js const freal equals new expedition mount freal to water snack. Export default freal. Export default can be used in place of export when you wish to export only one type. Arga. In both export and export default can be used on any JavaScript type. Primitives, objects, arrays, and functions. 4. Modules can be consumed in other JavaScript files using the import statement. Mod. ULES with multiple exports can take advantage of object destructuring. Modules that use export default are imported into a single variable. Import print log from /text-helpers. Import freal from /mount freal. 5 Node.js documentation, modules. 6 For up-to-date compatibility information, see the S6 compatibility table. Printing a message. Logging a message. Freal.print. You can scope module variables locally under different variable names. Import print as p, log as l from /text-helpers. P printing a message. L logging a message. You can also import everything into a single variable using import as fns from /text-helpers. S6 modules are not yet fully supported by all browsers. Babel does support S6 modules, so we will be using them throughout this book. CommonJS is the module pattern that is supported by all versions of Node.js. 5 You can still use these modules with Babel and Webpack. With CommonJS, JavaScript objects are exported using module.exports, as in example 2 to 8. Example 2 to 8. /text-helpers.js. Const print message equals log message, new date. Const log message, timestamp equals console.log timestamp.toString message. Module.exports equals print, log. CommonJS does not support an import statement. Instead, modules are imported with the require function. Const log, print equals required /text-helpers. JavaScript is indeed moving quickly and adapting to the increasing demands that engineers are placing on the language. Roses are quickly implementing the features of S6 and beyond, so it's a good idea to use these features now without hesitation. 6 Many of the features that are included in the S6 spec are present because they support functional programming techniques. In functional JavaScript, we can think about our code as being a collection of functions that can be composed into applications. In the next chapter, we'll explore functional techniques in more detail and will discuss why you might want to use them.